Hello and welcome back again. I'm Saksham Arora, your host for today's JavaScript tutorial. We're going to complete the pieces that were left off unjoined the previous time, but till more audience join in, I'll quickly wrap your head around what we did before. Firstly, we talk about how browser go about working on JavaScript. We talk about the language, features, and its different data types, its comparison operators, loops, functions, arrays, and its methods. Then we talked about objects and we had the glimpse of this keyword, the global context and the implicit, or what we also say, the object binding, also with that. Then we talked about the document object model, the selections and the manipulations. Also, the events were had the glimpse about. And we added JS to a calculator with all of these concepts out of thin air. And I also added switch statements and printing techniques with JavaScript at the end. Again, if you're directly here without watching that, I strongly recommend you to go and see once. I'll drop the links in the description. Well, in this section, we're going to see the execution stack and context, closures, this keyword to the extended parts, and object-oriented problem solving in JavaScript. So without any further ado, let's get started. The execution stack. Execution stack is also called the calling stack, and it stores all the execution contexts created during the code execution. Now, what is the execution context? Can you please explain? Of course I will. But first I would like to tell you that whenever the code is executed, it's different execution contexts are made, and those are made within the different scopes of our code. Before going ahead, I would also like to add a point that this stack has a LIFO structure, of course, like every other. If you have studied about data structures and algorithm, then you might have known this concept. So in this code, this particular section, that is the declaration of the origin keyword, is out of any other scope. That is going to be defined in the global execution context when it's going to be implemented. Plus, function part 1, part 2, part 3 are three functions that we have right here, and within part 1 we're executing part 2. Then if we go to the part 2 function, then we're calling part 3 within that, and part 3 has just one statement, console.log. So let's wrap our head around this. So we have function part 1, part 2, part 3, and if we start executing our code now, we'll start off with part 1. If we're going to start off with part 1, then in the execution stack, part 1 execution context will get pushed and the stack pointer goes up. Then in the part 1 execution context, we're declaring when 1 equals to 2019, and then we're console.logging the same state. Then we're hitting the part 2 state, and this is going to happen before closing the part 1 execution context, so it will stack above it, okay, and the stack pointer goes up. So in the part 2 execution context, there's just one console.log statement which says 1986. We're going to see that at console.log it, and then we're going to get part 3, okay. Before closing part 2, we are now getting part 3. So what will happen? Part 3 execution context gets stacked upon the whole execution stack, okay, just like that. Now that we are in part 3 execution context, we'll console.log this statement, and then we'll get out of it. How will we? This execution context of part 3 will just get popped out and the stack pointer will go down, just like that. Then in the part 2 execution context, we're now completely done with it. There is no further statement to be executed after part 3. So we'll left off this statement also. Okay. Then in the part 1 execution context, console.log statement was left to be executed. So it will be executed, and the function part 1 ends. So now that we are end with this, we're going to leave the part 1 execution context. And now that we're done with our function, the whole code, because our whole code just exists with part 1 function right here, we are now back again in the global execution context. Well, That's what I said. If you don't believe me, I'm going to show you this in the Chrome browser with its developer tools. Okay. So I'm just going to Control Shift I. Yeah, these functions were executed, but we're going to see how they worked. Okay, so I'm just going to copy this. Let's see. Yeah. So before execution of anything, I put a debugger in it so that we'll know what is going on. Okay. So before going to execute anything, we are now in the anonymous, that is the global scope or the anonymous context or whatever you want to call it. Then if we go further, we're now about to execute part 1 part 1 function, I'm sorry. So yeah, now that we're in call stack, and now that we can see that part 1 is stacked above the anonymous context, we're just about to log in to the part 2 execution context now. Okay, and yes, now that we're here, you can see in the call stack we have part 2 stacked above the part 1 execution context, as we talked about before. And now we console.log it. You can see that we just console.log this statement, and in the part 3 execute line, we're just about to go, and this, now that we're here, you can see the stack completely just above one and the other. Okay, and after this debugging statement, we're going to see in the console that 2052 will be logged after the execution of this statement, and yes, it did. And now that we are here at the last bracket of where it will end, it's going to lose the execution stack of part 3, and it popped out, and now we're further back to part 2. Now it's going to leave the part 2 execution context because we are at the last part of our function, and yes, we left. But we haven't completed the part 1, right? Because console.log statement of and now we're back in the future is still left. So as soon as we drop out this, we're at the end of the execution context of part 1, and we can see that this particular statement has been logged in. And now that we're done with this, now we can see that we're back in the global scope. The execution context has been ended, and all our console.logs are right in our place. And this when 1 has been destroyed with the execution context of part 1 function. Now we're no longer having this. Okay, so if I now say origin, then I can see the third world. But if I say when 1, I won't be able to see that because we're out of that scope, and in the execution context of part 1, we already made it clear that it's going to be no longer with us. Okay, so I'm gonna close this. So now let's move ahead and recap what is execution context. Execution context is an environment in which the code runs. JS Engine creates a global execution context by default before it starts to execute any code. Okay, variables and functions that are not stored inside any functions are stored in this global execution context. Whenever a new function is executed, a new execution context gets created. I hope you get all these points. So now let's talk about nested functions. What are these? Well, whenever a function is executed within another function, or if a function is returned by the return keyword within the function, it's known as nested function. So for example, in this case, the function first keyword has a variable eva that says we are the light, and then it returns a separate function that is second world, in which the return keyword says eva plus Adam wants the apocalypse to happen. So as it's seen that if we execute first world with just one pair of brackets, then it returns the complete function of second world. Okay, but if we type the function with two pair of brackets, then we see that we get the value of eva concatenated with Adam wants the apocalypse to happen. So it's observable that we do not need the keyword second world to be named, or I want to say that the function has not been necessarily named, but it's always good to name your inner functions to debug if any problem you're going to have. Okay, but before going any further, can you find something fishy about this? Yeah, because there is something, and you might not be able to see that. So we talked about that if a function has a return keyword, it will end the function if that keyword is executed. Okay, so inside this first function we have a return keyword which returns the second world function. That means that first world has already been returned, and if it's returned, then the variable eva which was defined in the first world scope was destroyed. Okay, as we talked about before, and we'll see that in the next one or two slides also. But as I said, that eva should be destroyed, but second world is using that same variable eva with its same value. How is it doing that? Shouldn't it be saying undefined Adam wants the apocalypse to happen rather than we are the light Adam wants the apocalypse to happen? Well, in these cases, a term called closure comes into the topic. Okay, what closures do is they remember whatever the inner functions, whatever variables the inner functions are using, which are part of the outer functions. Okay, so that whenever those functions get out of the context, the inner functions have always the table of content, and they get remember anything. Okay, they can remember anything and they can call back anything from that table. Okay, so now let's see that what are the specifications for a particular thing to be a closure. So closures are used for nested functions that we talked about. We don't need closures for just anything. They are typically used for nested functions. Okay, a closure is a function that makes use of variables defined in outer functions that have previously returned, as I talked about. Okay, but closures only work if the inner functions are using those outer variables. And for a closure to work, you should always return the inner function. Okay, so in this comparison, as I showed here, this particular example and this particular example, this is a closure because it's using eva, which was declared in the outer function. But this is not a closure because it just returns the string which doesn't have any relation with the outer function. Okay, so now that you know what are closures, what makes something a closure, let's go ahead. How does closure works? Well, this is a real-time function to be implemented, so maybe I should go to the Chrome browser and type this function out for you. Okay, so type Chrome, open it, Control Shift I to open the developer tools, then Control to clear it all off, and now I'm going to write this complete function. First world there was, then in that we had our eva. Yes, what we got in here? Oh yes, I've executed this, so it got remembered and it showed me up. Bingo. Yep. So we declared this function and now we're about to execute it. So I'm gonna type first world, two parentheses, go to the inner depth of this function, right? And now that we are here, you can see that we have this second world in the calling stack. That means the first world had appeared in the previous time, but it has destroyed because the return keyword has been showed. So the first word has gone out of the execution context and we're here with second world, okay? And in the second world we're using Eva that says we are the light, but we're not using the Adam that says I don't think the second world knows me. So it is the case that the closures just remembers the keywords that are used in the inner functions, okay? It doesn't remember all of those variables which were defined before. So if I'm about to show you what I mean, that Eva has the value we are the light, but Adam is going to be undefined because we are in second world execution context and Adam was destroyed with the first world execution context. But with the help of the closure, we now can see that Eva has this value, and we always have known this value since so far. And now we're about to execute this return line. So let's do it. And we did. Okay, so now we're back in this anonymous function. Okay. Yeah. Now everything just ended. Our function got over because we just had one function to be executed, and we can see we are the light. Adam wants the apocalypse to happen. Okay, that was cool. But close this, and we're back to our slides. Closures can also be used with private variables. What does that mean? Well, in some languages, in C++ or Java, you've seen these concepts of private variables or object-oriented programming, OOPs and all. So in JavaScript, we don't have that functionalities. We don't have object-oriented supports, but with the already existing things that we have right here, we make these things up. Okay, we try to mimic the whole object-oriented problem solving concept in JavaScript. So with this closures, these things can be achieved. Okay, but why do we say that these variables are private or we have closures working on it? Well, in this particular function, let's zoom it a little bit. Okay, counter is a function and it returns another function which has this variable in use, which was declared in the outer function, which is count. It was initialized to 0 and it was set in the inner function that whenever this variable is called on, it should increment its value, and this function returns this count further. So now that we know that if we use just one pair of brackets, it will return not just a value but the complete function that was to be returned. Okay, so we store this function in counter1. Now counter1, when being called, it's same as we called the first word function with two brackets. It's just now that counter1 is counter with this bracket. Let me just write it. Counter1 is nothing but counter with this pair of brackets, and we now add this further pair of brackets so that we mean that we're calling this function to the inner depth, and this is executed right here. Okay, counter1 has returned the count variable with one value incremented. If we call this again, then it again increases its value. But what is the concept of private variable in this case? It's just using closure because the count variable is being used, which was declared in the outer function. Well, if you define another variable which says counter2 and reassign this to counter function, that was the outer function, it's going to return this function and store the inner function in counter2. Okay, so when counter2 variable is being called, the value is going to be 1 and not 3. Okay, and when it's called again, then it's going to be 2, like we had in the case of counter1. And if we call upon counter1 again, then it's going to be 3, because we left counter1 at the position 2. So these counter 1s and counter 2 are not disturbing each other's work. Okay, so they are not hindered and they keep themselves private. Okay, so we can carry both of their works as we like. Before moving on to this part, I would like to give you a recap of what we had last time with the keyword this. So we talked that this keyword, when used within the global context, refers to the window object. Okay, that meant that if we are having a function that uses this keyword without a declared object, this keyword used in that function referred to the global execution context. If we have a declared object and we do not have the function in it, then this keyword also referred to the global context. Okay, so what we see that we need both the declared variable and the function to be used for this keyword to be referred to the declared object. Okay, but if we see this case again, that we are console.logging this and we get window, because this is just to show you that we're in the window context. And now that we are executing function determine this, which is return this, when determine this is being executed, it again shows me the window. But for this function, nothing is defined as the declared object. Okay, it's an anonymous scope that we are in, an anonymous execution context. So shouldn't it be undefined in this case? Yes, it should be, but JavaScript located it to the window object as far as it could. Okay, but that shouldn't be the case. If we are to disable this mistake that we are unknowingly doing, for this in ES5, a previous version of JavaScript, they provided a keyword strict to help us write better Java codes. With this, we are eradicating this mistake that we used to do. So as we can see in this example, determine this is returning the window object, but however it should return the value undefined. Okay, so if we are to use strict, then in that case console.log will give you the window object because it's in the outer scope, but determine this will give you undefined because there was no object defined for this function to hold. Okay, now we left this keyword with explicit and new keyword. Okay, we talked that global context and implicit binding are required for the basic functioning of JavaScript, but explicit binding and the new keyword usage is kind of a part of the advanced portions of JavaScript. So in the implicit binding or the object binding that we talked about before, I stated this example and I executed person.toMe.sayHello function, which returned hello undefined. Why did it do that? Because in toMe object, we are declaring sayHello function, which returns hello plus this dot first name. Now this keyword here should refer to toMe object according to the implicit binding, which says that this keyword should refer to the closest parent of the object in which the function is being used with this keyword. Okay, now this dot first name, if it's referring to toMe object, then in toMe object there is no property to be called upon this dot first name, and so it will return undefined. Okay, now as a solution I provided you that you can define a new property for implicit binding to work there. So I defined person.to_me.firstname equals suction. And then if I called person.to_me.say hello, then it returned hello plus suction. But it's not a very precise solution, okay? It's clearly not the case that we can always do that. This is obviously not professional, this is inefficient, and there is a lot more that we can do with explicit binding. So apart from creating another property in a already defined object, what we do is we explicitly bind our this keyword to whatever object that we want. For example, in this case, we want the this keyword to be person explicitly. Okay, implicitly it was bound to me, but we want it to get bind with the person object, and that's what we're going to do with the explicit binding. So for explicit binding to work, you need to use these explicit methods, which are call, apply, and bind. Okay, and with these functions in action, you can see that we're not actually defining another property, we're not actually declaring another property in to me object. We're just calling or applying or binding this person object to this function, and it works magically. Okay, so without any further ado, let's just see what these three methods are and how it's used. Is it any further use of these three methods apart from this, apart from explicit binding? We're going to see to all of these questions. So these terms of call, apply, and bind, we're going to have a great look at this in the coming 5 to 10 slides, I guess. And these methods are obviously used when we want full control over what the term this will be, and these methods can only be evoked on functions. As I did before, I called these functions with say hello. Okay, and I would also like you to notice that I didn't add these parentheses which I used to at say hello. Okay, I just added to the function definition these methods all along. Okay, well, we'll see to it, but okay, let's just compare these three first. So these three methods are useful in their own ways. Call, apply, and bind are these three methods, and these are the properties. Number of parameters that they're going to take is this keyword and any further arguments that you want them to take. Call and bind can take infinite number of arguments, whatever you want to use with call and bind in that invoking function, you can use that. Apply takes just 2 arguments, but in the second argument it takes an array, and that can be of infinite number of length. Okay, that array can store as many parameters as you like. It's just the way of working of apply that it takes these 2 parameters, and it's useful, it's very useful sometimes. Okay, and we'll see to it. But bind and call might seem a bit similar, but they're different in their own ways. That's call says that it takes this argument and these parameters, these number of parameters, and it's evoked immediately. Whenever you'll call it, it will evoke. But bind will not evoke immediately, it will evoke some time later, or in whatever time you may want to call it. Like in this case, I wanted to call it right away, so I told that bind person, and I gave these brackets. Now you might be thinking, what the hell, these brackets were not here, so why is it coming here? Well, these brackets were not here because these functions returned this statement right here. Okay, with this keyword being referred to the object person that we told them to be. But if we are to say about bind, then bind without these brackets is going to give you a function definition. Okay, bind is going to give you a function definition which says hello plus this dot first name, and if you want to evoke it, you have to further add these brackets as the invoking function. Okay, so this part right here before these pair of brackets is actually a function definition and not a returning function. If you have to invoke it, you have to add these brackets after it. Okay, now let's talk about these in detail, and let's first talk about call. So we do not evoke the original function with these brackets, as I told you. We do not say hello brackets dot call and person. We just say hello dot call person, because we are attaching this method to say hello, which is a method, and that's why I told you that call, apply, and bind can only be assigned to the functions. Okay, and this can be used to refer that say hello, whatever this keyword means, this keyword should refer to person rather than to me. So in this line we are explaining JavaScript to execute say hello function but call person object rather than to me to be taken value of this dot first name. Okay, and call is also used to avoid code duplication. How does it do that? Well, in this code example I have two objects. Okay, first name Saksham say run, and it will call Saksham plus run. Well, this is being repeated the same way in another object, that is Vyom. How can I avoid that? So what to do if you do not want to write the same code again? Well, we can use call method to explicitly set the reference of this to be the first object created. Let's see what I mean by that. While Saksham is declared with the first name property and the say run method. Well, apart from this, Vyom object is created with just the first name property. We did not write say run again. We did not duplicate this particular method. We just had this property to be named. Okay. Now Saksham.sayRun says Saksham run as it should, because this here refers to the closest parent object, that is Saksham. Okay. But with Vyom, what we did is we called the same function but replacing this keyword to take the reference of Vyom. Okay, so Saksham.sayRun.call Vyom suggested JavaScript that okay, run this function but change this keyword to take the value from Saksham to Vyom explicitly, and now it says Vyom run. Okay, and we can also generalize this function so that every other object with first name property can use it. And let's say, for example, if in the global scope and not in a particular object, we're defining function say run with this return statement that says this dot first name plus run. Okay, and then we are saying Saksham first name and Vyom first name. It didn't require us to even write the say run method in the first Saksham object. Okay, and now we do not need another object before say run to be called upon for this function to use. Okay, so now that we're saying say run dot call Saksham and say run dot call Vyom, it says perfectly Saksham run and Vyom run. It doesn't matter much. Okay, and one more thing before we go, that in the previous times I told you that these HTML collection that we talked about in DOM, it was to declare that this particular divs were to be assigned particularly one by one with a for loop, and the fact that you cannot use a for each to do so. Okay, but I also stated that in the next tutorial I'm going to talk about a technique with which you can use for each also for converting this particular HTML collection to an array, a proper array. And how do we do that? Well, we declare divs array another array to be defined, and with that I use an empty array with the dot slice method. And if I do not give any parameters to it, that just means that it's going to take whole of this divs collection, and then it's going to copy that complete collection to this divs.array. But there's just one thing that is needed to be remembered, that is the call method. If we are going to give slice and we're going to take this divs into it, then it won't work because divs is not an array to be defined. Okay, but now that we're calling divs inside the call method, we're going to convert an array like object to an array. Okay, so in that case it will assign divs array to the converted portion of the divs HTML collection, which was an array like object. And now that we implement divs array, we can see that 200 elements are there inside the divs array. Also, now we can use a for each for this. If we were to access this links in HTML collection with for each, we would get a type error, because a for each can only be worked with an array, and links in here is not an array. Okay, I've just selected all the elements with the A tag on the Google page, and with that I was trying to implement for each with it, but it won't work. What we can do is we can create a links in array and we define it the same way we did for divs, and with that links in array we get 16 links that are on this page. Okay, and after that, if we implemented this links into links in array, we can use this for each to be implemented in this. Okay, and now it works correctly, and we can see a 2-pixel solid red border around all the A tags around here. Okay, the other function after call is apply, and it's similar to call except for the parameters part that says that first keyword has to be the keyword this, or whatever the object you want to refer to it, and the next set of parameters is not an infinite number of parameters, it's just one array of infinite parameters. Okay, by infinite I obviously mean that you won't have to take infinite number of parameters, that's just hypothetical, but you can take as many parameters as you like. Okay, well, while call and bind can take infinite number of parameters, apply just take 2 as I talked about, and let's move on. Now, why is apply a separate function? Why can't we just go with call or bind with the previous versions? Like call was doing the same thing too. There can be other uses. For example, math.max is a function which calculates the maximum of all those parameters that are defined inside the max method, and in this case it's 345. But what if you have an already defined my array in your set and you want to use it with math.max? Well, it won't be anything. It just give you a not a number value, because math.max takes numbers as parameters, and you're not declaring and you're not giving in the argument section my array. Well, you're actually giving my array and you're not giving these numbers. Okay, that means in the place of numbers you're giving an array, and that means nothing. But to make sure that means something, what we do is we apply this particular code, and this is math.max.apply this comma my array. Well, my array is this array that we declared in here, and as we talked about, apply takes 2 parameters, that the object that we want to relate to and the array of parameters that we want to give. So in this place we are going with this keyword right in this case. And it works the same way as the window object does. Well, this is the generalized part of this window object. If you are not using mat.max in window object and you're using it in some different object, then you can use this keyword right in that place. It will work everywhere. Okay. So now that we know that apply can do a lot more things than call, let's just see that what apply can do in written state. When a function does not accept an array as a parameter, we can use apply to spread out the values for us. Also, in this particular example, we're not concerned to explicitly set the value of this. We just care about spreading an array of values out. Okay, so in this case, we were not declaring this to be something else. We just wanted to have this mat.max function work with an array, and that's where the apply method was used. We used. Okay. Now let's talk about bind. Bind works just like call, but instead of immediately evoking the function, it returns a new function with the value of this bound to the first parameter that we pass with bind. Okay. So for example, person.me.sayhello.bindPerson was a function with which we add a separate pair of brackets, and then it worked. But when it's useful, let's see ahead. But I talked about it returns a function. Why does it do that? What is the use? So it is needed when we code asynchronously. Now what does it mean? Synchronous coding refers to the type of coding in which when one function is not completed, when work is being done, you cannot do any other work. Asynchronous coding comes when you want to simultaneously work on different part of the code. That means you might be working on it while some part is executing right at that time. And bind can also be used when we do not know all the arguments initially, and there is some calculations, and after that we know the rest of the arguments. Okay, so in the case of asynchronous coding, I'm going to give you the example of set timeout. It's a function defined in the window scope, and I'll just explain it to you. Set timeout takes two parameters. The first one is a callback function, which is this right here, and the second argument is number of milliseconds after which the set timeout function is going to be executed. So now that I've said the statement, what does it mean? Set timeout, when executed, counts the number of milliseconds that we specified, and after that it starts to execute. That means you can code some other parts of your program while set timeout is being run in the background. Okay, so if I say Sammy.say hi, after 1 second it will give hi undefined. Well, this dot first name should refer to Sammy because obvious reasons, because we have a function running on, and this function, well, it was declared inside of a declared object that was Sammy, so it was assumed to be hi plus Sammy instead of hi undefined. Well, of course it was assumed that to be, but you need to remember that say hi is now executing set timeout in it, and set timeout is executing after 1 second of a time. Okay, it's executing after 1,000 milliseconds. So that means by that time we'll be out of the scope of Sammy, and now that we are out of the scope, JavaScript won't know which is the first name property in this, because this will then refer to the window object in which the set timeout was defined. So window.firstname isn't a property already defined, and that's why it said hi undefined. What we can do is we can set this function to take bind with it and to add this into it. Well, this here means that we are referring to Sammy, because sayHi function is declared inside an object Sammy, and this keyword here will refer to this particular part. And when Sammy.sayHi is now called upon, it says after 1 second, hi Sammy. It perfectly worked as we wanted. Okay. And as I talked about the case where you don't know what all the parameters are, you can think of this example. Let's just zoom it a little bit. And this is the function add numbers, and it returns this dot first name just calculated a plus b plus c plus d. Whatever parameters that we given here, they are to be calculated in this condition, with this condition. So I'm declaring an object Saksham which has first name property as Saksham, and Saksham calc is a variable that stores this particular function. As I said, bind will return a function. That means that this particular portion right here is a function, and we execute Saksham calc. Now we can see that this is a function. But if we execute Saksham calc with a pair of brackets, then it will show us Saksham just calculated 10. But if in the case that you don't know what are the parameters to it, then we can say var Saksham calc add numbers.bind Saksham 1, 2, and then afterwards, when you get to know what the other parameters are, you can then declare Saksham calc 3, 4. You can then execute it to have all of these parameters that were left added to this particular return statement, and then it will return Saksham just calculated 1 plus 2 plus 3 plus 4, that is 10. Okay. Now, explicitly binding was a lot to deal with, and if you have any problem to deal with that, you can obviously drop those in the comment section, all those doubt of yours, and we're happy to help you. Moving ahead, there's just one part left with this keyword, that is the new keyword. Okay. The new keyword does quite a bit of things and will unleash the full potential of it in the object-oriented programming. But for now, let's take a look at this example. Well, we have a function me right here, and in that function, I'm assigning this dot first equals first name, which is this parameter, and this dot last equals last name, which is the second parameter. Now I'm defining var Saksham as new me, which says in the parameters in place of first name and last name, it says Saksham and Aurora. Now if I execute Saksham.first, it says Saksham, and Saksham.last says Aurora. Well, it shouldn't be like that. Why? Because this function is declared in the global scope. It's not declared in an object. Okay, it's not in the declared object which has these properties first and last. But here we are using this new keyword, which is absolutely new to us, ironically. But what it does is it creates an object. Whenever this new keyword is used, a new object is created. Okay, and the new keyword is used with the function, and inside of that function definition, the keyword this now will refer to the new object that is created. Okay, so that will refer to the Saksham object that is created, and this is going to have this first and last properties as declared in this Saksham Aurora, and then we can access these properties. Well, this seems like a lot, and actually this is the basis of the object-oriented programming, because this function right here is a constructor function. Okay, and we use these constructors to make new objects which we can use further. But let's just first see what will happen if we do not use this new keyword. If we are to directly use this me function right here, Saksham will be undefined. Okay, and that was kind of an obvious thing to begin. Let's just move ahead to object-oriented programming section. This is the programming model which is based on the idea of objects. Okay, here objects are constructed from classes, and which we can think of as some blueprints which we already know. It's like a template. And when we construct objects from these blueprints, we traditionally call them as instances. Okay, our application will now be able to use abstract and modular codes for enhanced implementations, for reducing duplications, and many such advancements. But JavaScript does not have built-in classes support. It does not have oops supporting in it beforehandedly. So how do we going to achieve this? We make the use of what we have currently, which is function and objects. Let's see to it. Imagine that you have a data set of houses. So in house 1 object, you say bedrooms, bathrooms, square feet as 2 to 1000, and house 2 has the same way, house 3 has something the same way, which can be differed, of course. But let's just think that if we have 1,000 number of objects, okay, or 100, 1,000 number of objects like this, are we going to type that again and again? Firstly, it would be repetitions that we're duplicating it all along. Secondly, these objects here can be implemented in a better way, which is much more efficient, time saving, and less repeated. Okay, so what we can do is to create a blueprint that will create these objects for us every time we call that. And with that, whenever we call it, it will construct a new object for us. So this is that blueprint looks like. And you might be thinking that these properties here are exactly the same to these parameters, but it doesn't have to do anything with this. We just call these properties and these parameters the same because we want things to be known before. Okay, if we have said that bedrooms are being called as 3, 2, and 1,000, then we want this property to be bedrooms itself. Okay, as you can see that this is bedrooms and this is bathrooms, this is number of square feet. That's why we call these properties to be the same as these parameters. Otherwise, in the previous version of this, as I said, here in this first property was not exactly the same as first name. Okay, so is this the case? Now, we use constructor functions to reduce duplication in our code. We'll further use copy and apply to refactor constructor functions. That means we're going to use constructor functions, and in fact we're going to use call and apply to refactor that code. That means we're going to use these methods which we talked about in explicit binding to further advance these codes. Okay, and his is another example, which is a blueprint of a person, which says new, height, weight, and hair color. These are 4 properties, and we're declaring these properties just as the way we did in the previous example. And we're going to use this, we're going to declare these 2 constructor functions with these 2 new objects, and it will declare that for us. Okay, these things are to be noticed when we talk about the new keyword. First of all, it creates a new object, an empty object. It then sets the keyword this to be that empty object, which is used in the function with which the new keyword is being used. Okay, it then adds the line return this to the end of the function which follows it, and this is done implicitly. You won't be able to see that. It adds a property onto the empty object called double underscore proto double underscore, which is also known as dunder proto, which links the prototype property on the constructor function to the empty object. Well, this might have you scratch your head around, but don't worry, we're going to see the last 2 points in great detail. Well, talking about the third point, this is just being in the background of the code, and this is just being done so that we can access the object which we are declaring. Okay, but the fourth property is a lot to deal with, and we'll see it for a couple of slides. But before going to that far, let's just talk about multiple constructors and how we can use those methods, call and apply, which we talked about in explicit binding here, so that we can further refactor our code. Well, this example states two functions, these two constructors, and these constructors are car and motorcycle, which has all these properties in the same way that these are, but just the difference is these two products are different, and the models made from these products will be different, and they have to be kept different. It's just they have the properties which are one of the same way. So is there any way that we can reduce the duplication we are doing in motorcycle? Because if it were to be 100 properties than just these four, which it can obviously be, do we have to type or write all these properties again and again? No. We're going to refactor our code to further make sure that duplication is reduced. We want some way to borrow the car function and invoke it inside the motorcycle function. So you might be thinking, why don't we just call the car function inside the motorcycle function? Well, the problem here is when we call the car function, the keyword this refers to the object that will be created from the car function, when obviously the new keyword is attached with the car constructor. But that's obviously not what we want. We want the constructor to refer to the object created by the new keyword, which is not some other object, but the one that was correspondingly created. So what we want to do here is to change the value of the keyword this to be the object created from the motorcycle function. We won't be taking bind as an example because we don't want to return a definition, but let's look at call and apply and see which one is better, because these are the only ways with you can explicitly set the value of this keyword in the way that you want. Well, this code which I'm now going to discuss is pretty confusing. Okay, so I'm already giving you the disclaimer. So after you see what I'm going to talk about, pause the video, try to analyze it yourself, and maybe even play around it in the Chrome console. Okay, so let's just see what we're doing with it. Instead of duplicating code from the car function, we invoke the car function but change the value of the keyword this to be the keyword this. As you can see in here, instead of duplicating code from the car function, we called the car constructor but changed the value of the keyword this to be the keyword this. I'm going to repeat that sentence again, and now I'm going to make some doodles all over it so that you can have a better understanding of what I mean. So instead of duplicating from the car function, we invoked the car function inside the motorcycle function but changed the value of this to be the keyword this. You get what I'm talking about? Well, this keyword right here referred to the object that has to be created with the car constructor, but the keyword this is going to be a bit different from this keyword right here. When we'll call the motorcycle constructor with a new object that has to be created, this new keyword is going to set the value of this keyword, which is used in the motorcycle function, as the value of the variable, as the value of the variable which is now declared as a new object. Okay, so with this new keyword right here, we are actually indicating JavaScript that change the value of this not to be the function, to not to be the variable which has to be associated with the car function, but with the variable, with the object that is to be created right here as motor. So this now relates to motor, okay, and whatever the values we are going to pass in make, model and year, that are true, 23C and 2019, these values are going to be taken by call and set as these particular parameters right here, okay. So as a recap, what we wanted to do is we want to borrow the car function and invoke it inside the motorcycle function. The problem was this keyword in the car function was related to the object that has to be created with the car constructor. But we did not want that. What we wanted was to create a motorcycle object with the motorcycle constructor. And we wanted these duplications in the car constructor to be reduced in the motorcycle constructor. So what we did is we call the car constructor, but with the reference of this to be changed with the keyword this, while being the keyword this different than it was before. Before, without the call method, car was referring to the object which was created by the car constructor, but now this keyword right here is set as motor with the help of the new keyword right here, okay. So this keyword here and this keyword here now refers to the motor object, and these three parameters are now related to these three parameters right here. I hope this concept is a lot clearer than before. Moving ahead, here we see that we're using call function, but we can also use apply in place of it, and we can put all these parameters inside this type of an array. And these parameters inside this array, it makes no sense because it's just the same thing as we did for the call, but it will actually be a better implementation if we were to use, let me just zoom in a little bit if I'm about to do that, okay, yeah. So we can also use the arguments keyword in place of these array that we were thinking about to use. How can we do that? Well, whenever a function is created, two keywords are assigned to that function, this keyword and the arguments. The arguments is an array of all those parameters which are invoked in it. Well, it's not exactly an array, but you can think of it right now, okay. So we can deal with this problem of ours in this really simple way, which is car.apply this comma arguments. And as you can see in the comments, we don't need to even pass in parameters, even better using apply with arguments, okay, because in the call method we had to pass parameters, but we can use the arguments keyword to go hand in hand with the apply method, which will do exactly the same work but in a shorter, refactorized manner. It's more enhanced, it's more advanced, and it's pretty interesting to see, okay. So let's move ahead. So now we're going to talk about prototypes. Before starting off directly, I'm about to revise you what the fourth property of the new keyword was. So it creates a link between the object created and the prototype property of the constructor function, which we can access as dunderproto. Okay, so this link which I'm talking about, which connects the object created and the prototype property of the constructor function, is dunderproto. Let's see it with a diagram. So in this diagram, this circle is a constructor function, and the rectangles and the squares which I'm going to use are objects, okay. So every constructor function has a property on it called prototype, which is an object, okay. So person.prototype is an object, and the prototype property is a property of the constructor function. the prototype object has a property on it called constructor, which points back to the constructor function. And you can see a long loop going on here. That is the constructor function having the prototype property, and then it makes an object, and that object is further linking the function with another property called the constructor property. Okay. And if properties and methods are placed on person.prototype, they can be accessed from any object that are created from the person constructor. Okay. So finally, the way in which these objects are created by these constructor functions have access to the prototype properties, and this access is made through a link called underproto. Anytime an object is created using the new keyword, a property called underproto gets created, linking the object and the prototype property of the constructor function. Let's see it with a code. So the constructor person is the constructor function here, and it just takes one argument, which is then used as this.name equals to the name. Okay, and these objects are created from the person constructor. Since we use the new keyword, we have established a link between the object, which is this object, and the prototype property of this constructor function. We can access that using dunderproto. So this object with dunderproto links to person.prototype, where person was the constructor function. And if you implement this, if you execute these two lines, it will result in true. The prototype object also has a property called constructor, which points back to the function which we talked about. If you implement this or execute this line, it will result true. Well, the constructor function is not meant to be manipulated, or it's not oftenly suggested to reevaluate it, reassign it, but it's an important part in inheritance, which we'll see in just a while. In the previous slide, I told you that if properties and methods are placed on person.prototype, they can be accessed from any object that are created from the person constructor by the link called underproto. Let's see it. So this is the constructor function here, which is having just one line being executed as this.name equals name. This is an object created from that person constructor. And with the new keyword being used, we are now creating a link between this object's prototype property and with the object's dunderproto property with the constructor function's prototype property. Okay. So if I set person.prototype.isHuman as true, what I'm actually doing is I'm using the dunderproto link while implementing these two codes here so that I can get true as the result. What just happened here? Well, these two objects weren't supposed to be related to this, okay, because we changed this line here to be true, and it actually went on implementing these two lines to be true. So the answer lies in dunderproto. Okay, as I said, these objects have a link known as dunderproto, which points to the person.prototype object. If we add methods and properties to this object, then we can access these properties and methods with dunderproto. Okay, but we didn't use dunderproto after this. We straight away used .isHuman. How are we doing that? Well, this is actually the case of prototyping chain. Okay, and let me put a disclaimer in front of this that JavaScript, while finding its methods and properties assigned to the objects or arrays or whatever it uses, the prototype chain goes all around. Let's see to it. Well, let's take the example of an array. If I declare, let's zoom it a little bit. If I declare this array as empty square brackets, I'm just doing the shorter way of this particular line here. What I did is I created a new object which was created by the help of a constructor function array. This array is predefined in JavaScript libraries, and with the new keyword I'm creating an object called ARR, or I'm going to say R. So yes, you can think of an array as an object because it's created from a constructor function with a new keyword. And that's nothing wrong because this array is going to have properties just as the way the objects did. So yes, arrays are a type of objects. Okay. Now, if we are to add dot push in front of ARR, it's going to give me this function which is predefined in JavaScript. Now, how does JavaScript knows that this function is somewhere? If we go about doing the dir of array, that is finding in the directories of ARR, we'll find that there is just one property, that is length, and push is not there. So how does JavaScript knows that push is somewhere? Well, the answer lies in dunderproto. If I now implement ARR.dunderproto, it will give me these huge tons of properties in JavaScript library, and push is one of them. So this is the prototype chain. If JavaScript doesn't find dot push in the ARR directory, what it will do is it will go into the dunderproto and then tries to find it. If it finds, then it's okay, and if it doesn't, it further goes to the dunderproto of ar.dunderproto. Okay, let's open the Chrome console for doing that. Let me first show you what is the example that I previously talked about. So I'm going to create var equals to a, or this is just another way of doing array. Okay, now this array has a push method, it has a length method. Okay, but if I now check the directory of dir, or in the full version of it, it's called console.dir, it gives me the array. Okay, now array doesn't have this property, it just have the length property. Okay, it doesn't have the push property. So how does JavaScript know that there is some push property in it? It checks the dunderproto of it. So let's just expand the dunderproto, and now I can find the push property. And let's just now gain another example. So every array has another property that's called has own property, and which returns a boolean value if a particular property is present for this array or not. So let's say length, that returns true, and if I say something like pop, not pop because it's not in the property length of dot array directly, if I say foo, it returns false. So how does JavaScript know that has own property isn't somewhere? It uses this dunderproto right here. So if we again go about doing the directory of ARR, then it will give me this array expanded, and has own property isn't right here. And if I go about checking the dunderproto of it, has own property isn't in this one too. So let me just check the dunderproto of this even further. Now we're having it. And after this, dunderproto is not present. That means if this property was not present in here, JavaScript would have returned undefined because it couldn't find through the prototype chain also. If it were in the case of length, it was directly in the properties of the array constructor or the prototype of it. If it was the case of push, it was under the dunderproto of array. If it was the case of has own property, it was under the dunderproto of array. Okay, but if it's the case of array.foo, it will give me this type error that foo is not a function. Okay, So that's how JavaScript goes on finding its properties through proto, and it's called the prototype chain. If it was able to find in the air construct the object that we just made, it's okay. If not, it then goes to the proto and tries to find that method or the property in array.prototype object. If it was found, then okay. If it doesn't, then it goes to its proto of the object.prototype. If it found in that, really good. If it doesn't, then it goes to the next proto until this chain stops and the JavaScript fails to find the property that we are looking for, and it gives back undefined or a type error. Okay. But what's exactly the use of this prototype? We understood the topic, we understood the concept behind this prototype, but is there any use of it? So let's just look at this particular example. In this example, I've declared the say hi method inside this person constructor. If I now call this object with this new keyword, it's going to construct another object for me, which is suction. So I'm going to attach this method say hi, which says hi suction. Now, this particular method, whenever we execute this line, it redefines. Okay, JavaScript redefines this particular method every time we make a new object. So, but this is inefficient. We don't want repetitions in redefining. Okay, we don't want repetitions in definitions, and that's where we can use the prototype property. So what we'll do is, with the person.prototype object, we'll define .say hi as a function, and it will do the same work with just one definition. Now we're not doing repetitive definitions, and it's better and it's efficient to use. Okay, so every time when I create a new function, that particular function is already defined and can be redirected with proto, so it won't be inefficient anymore. Okay, now let's talk about inheritance. In this particular code example, we have the same person constructor, and with the prototype property, we are declaring the say hi method as we did before. The work of this is to return hello suction space Aurora. Okay, so but here we are adding one thing. There is this student constructor in which we are doing the same thing as we are doing in the person constructor. Okay, but we are redefining this particular statement. It's a repetition. Well, it's just a small example, but this repetition can be really heavy in practical usage. So we want to eradicate this repetition. Can there be a better way to take stuff out of the person and pass it to the student? It is through inheritance, in which we can take all the properties, all the prototype, which is declared in the prototype object, from the person to the student. Well, there can be a thought in your mind that let's just assign student.prototype to be person.prototype. It's just the way that everything can work. If we assign that property, everything in the person.prototype property gets copied into the student.prototype. And it can really work, but it's just the way of JavaScript that it won't. Because this particular thing right here, if we are assigning, it's not really being assigned in the background. What it's doing is it's making a reference of student object to the person object. So if you're about to change the student property, it's actually going to make changes in the person property. And it shouldn't be like that. If you're talking about inheritance, then properties from the person object has to be copied into the student object and not the other way around. So if you're doing this way, then student.prototype can change the properties in person.prototype. And that's not what we wanted. Okay, so if this particular line is executed, then student will have the say hi method, which was declared in the person.prototype. because we here made a reference to the person.prototype through student.prototype. Okay, and this function will work. As you can see, it will execute hello Saksham Arora correctly. Okay. So here's the problem. If we now change the student.prototype object and we add a method status which returns I am currently a student, that will affect the person object also. Because in the example shown here, if I create Saksham, which is an object, and that's made with the person constructor, which does not have the status method in it. But if we try to check it, Saksham.status returns I'm currently a student, which is wrong. Because this is not what we wanted. We wanted the student constructor to take on properties from the person and not vice versa. And as I told, this is happening because JavaScript doesn't copy exact objects to one another. It just creates a reference if we assign student.prototype as person.prototype. Okay. So here's the solution. Object.create. Okay. This object.create creates another object whenever you assign the student prototype as person.prototype. So if we try to implement this code section back, then Saksham.status is undefined. It won't return this function definition back. Okay. And that's correctly implemented. And one more thing to be added to this is you can see that we are using object.create, another function, another introduction. Okay, but there can also be a way to use new keyword, because that also makes a new object every time we declare it. But the problem with that new keyword is it will also define some unnecessary methods and properties to it. And we don't want that. We just want the person.prototype to be exactly same as no, actually we want student.prototype to be exactly same as person.prototype. That's the only reason why we used object.create in it. Okay. And just one last thing to be added in inheritance portion, that the student.prototype.constructor, if you are about to check, it will be pointing to the person constructor, and that shouldn't be the thing, because we talked about before that every prototype object has a property constructor related to it. Okay, every object has the property constructor, and that property takes this back to the constructor that we talked about. But in this case, it's the person that we are talking about. Okay, so object.create doesn't assign this whole dot constructor thing to the person. So what we can do is we can manually assign that student.prototype.constructor as student, so that it's just back in its place and it won't matter in any way what we're about to do. Okay, and this is one last necessary step in inheritance that we're about to make. So inheritance is not a bigger practical topic, but the theory should be known to you. It just have two steps, which is first one is the object.create method, and the next one is assigning the dot constructor property as the original constructor function. Okay, so that's all what I had to deal with and sharing the advanced concepts with you. I also talked about ES6 in the previous video, that I'm going to show you what are the modern ways of writing JavaScript codes in it by using ES6, or maybe even further ES7 and 8. But as we are shorter in time, I'm sorry to say this, that we have to stop this thing right now, and we might continue that afterwards. So in another section, I'm going to bring you further modern methods how to deal with JavaScript with ES6 and might be even ES7 and 8. Till then, happy programming.